Okay, the question was asked for the following. They said, one of the students said, well, look, I'm trying to find an antiderivative for 1 over 1 plus x squared dx. And they said the book's giving arctangent of x as a solution. Where does this come from? So what I'm going to do is I'm going to show you that if I differentiate arctangent, I do in fact get this guy right here. Okay, so what I want to do is I want to take a function, say y is equal to the arctangent of x, and what I want to find is what is dy dx. Because if I differentiate this and I show that it's this, then of course the reverse is this right here. So that's what I'm looking for. Okay, so I need to find this. Well, it would be very nice if I could just take dy dx of both sides here. If I could take d dx of both sides here. That'd be cool, but I can't. So what I'm going to do is I'm going to rewrite this, and we know that the definition of this is the following. It says that the tangent of y is equal to x. That's what this right here means. So this right here says give me a value such that the tangent of it is equal to this. So what we're saying is the tangent of y is equal to x. That's what this guy says right here. Okay, so this exists. Okay, this relationship. So I can go ahead and use this. What I'm going to do is I'm going to differentiate both sides. And so this is going to be d dx of the tangent of y is equal to d dx of x. Well, d dx is an operator, and it tells us to go ahead and take the derivative of whatever we see here. But I can't just take the derivative of this because I'm trying to take the derivative with respect to x of something that's in terms of y. So I need to use the chain rule here. And so what I'm going to do is I'm going to rewrite this guy here as dy dx times d dy of tangent y. Okay. Notice, and it doesn't really work this way, but notice that if I cancel this and this, I'd be left with d dx, which is this guy right here. It's a good way to remember it, but it's not necessarily the whole story. Now d dx of x, the derivative of x with respect to x, we know is 1. So now what I'm going to do is I'm going to take the derivative of tangent y with respect to y. So I end up with dy dx. Now what is this guy here? Well, the derivative of tangent with respect to y is secant squared y. And if you don't know how to get this, my advice would be to go back and say, okay, if tangent of y is equal to sine y over cosine y, and I differentiate this right here using the quotient rule, you'll end up with this guy right here. So if I keep going on, the idea is I want to find dy dx. That's the derivative with respect to x of this function y. Okay, so that's what we want to get here. So this guy right here is dy dx is equal to 1 over the secant squared of y, which means that dy dx, the derivative, is equal to cosine squared y. Well, what is cosine squared y? So let me go ahead, I'm going to draw out a triangle here. Okay, so what I've got here is I know from the original, okay, so we were trying to differentiate this. So don't forget what our goal is. We're going to differentiate this, and we're going to show it's equal to this thing here, which means the antiderivative then is arctangent. Okay, so we're differentiating this guy. Well, if y is equal to the arctangent of x, that means the tangent of y is equal to x. So what we're looking for is an angle y. Y is the angle. We want an angle whose tangent value is x. Well, tangent is this guy over this guy. So it's got to equal x. So this guy divided by this guy has to equal x. So the way to do that is to say that this is x and this is 1. Because then the tangent of the angle y is equal to the opposite over the adjacent. So I've just generated a triangle that satisfies this. Well, what is the hypotenuse then? Now, the reason I want to know the hypotenuse is I'm looking for what is the cosine of y. Well, we know cosine is adjacent over hypotenuse, so I need this guy. Well, that's pretty easy to find using the Pythagorean Theorem. I get this is 1 plus x squared, the square root of it, right? This squared plus this squared square root gives the hypotenuse squared. So that means that this is equal to this guy divided by this guy and then of course I'm squaring it because it's cosine squared. And so this will be 1 over. Now let's be careful here. When we square a square root, okay, we have to make sure that this guy here is positive when we give the answer. Thus we have to use absolute values. So, but that's all right because this is always going to be positive because 1 plus x squared, there's no way for this to be a negative number, no matter what values you plug in for x. So this guy's positive, and so square and the square root cancel each other out, and this gives me 1 over 1 plus x squared. So what we've shown is that the derivative of this function right here, the derivative d dx of the arctangent of x is equal to this guy. And so the antiderivative of this is equal to the inside guy here. And that's where that value comes from.